We're going to welcome Bogdan Stefanescu, CEE of Unstructured Data Solutions Channel Manager at Dell Technologies. Bogdan has over 20 years of experience in the field of data protection and security solutions, 9 of them in Dell Technologies. His actual role is to support partners' enablement strategy to build up the level of competencies of sales and technical teams. Yeah, sure.
Okay, I'm joking.
To assist them further to develop, build, and secure unstructured data-related solutions. Traditional data management systems like data warehouses have been used for decades to store structured data and make it available for analytics. However, the data warehouses aren't set up to handle the increasing variety of data, nor can they support AI and ML algorithms that require direct access to data. So we're going to find out more about that today with the help of Bogdan.
So. Yeah, I hope so. That's why I'm here, I guess. Thank you so much. So, are we the last on the stage today? I guess so, yeah? So, probably would be a nice joke to start with the last slide, right? To create a little bit of a different attitude or atmosphere. Anyway, I'm a box actually, not with X, so no boxing today. Still, it's a kind of wood, stage or something. But it was just a funny situation. Like many years ago, you see my white hair, so it's like talking about dinosaurs time, where somebody tried to play a joke on me. Actually, they were successful. Showing me like almost 30 years ago, Warp 2 machine, Warp 2. You remember? I'm not talking about Star Wars or Star Trek, but it was called Warp 2. It was OS 2 version of the server, and the name was Warp. And that was actually my first day working as a system engineer. And the guys there said, okay, this is the server, you do your credentials now. There was a time, actually, there were no rules creating your credentials. Okay, you couldn't use, trivial words or something, but there was not like first name, second name. There was like open market. And I was thinking about my name, pure Romanian, pure local, bloody Escu at the end. So I said, okay, should I use my name? I don't know who I will speak with, so let's find something else. So since then, actually, BOGS Box is the nickname which I usually like, then actually my initial name in the business. Indeed, I'm coming from Dell EMC. We work mainly in mid-market enterprise accounts. And we have, outside of what you probably know very much about Dell, I don't know, laptops, monitors, servers, compute, storage as well. There are kind of specialties inside Dell's which are working mainly on the vertical solutions, vertical or horizontal, whatever you consider artificial intelligence analytics. Probably it's more horizontal than vertical, but applying to multiple industries. And this is actually what I would like to talk about a little bit. Hopefully I will know how to press a button. Yes. I guess many speakers already today mentioned about, how this data capital means, how do you get the value of the different type of data, different type of logs, different files or even objects. So this is actually what a company considers now to get, even from the historical data, the value to improve the business. And of course, we know that this structured data, semi-structured data, and actually going to full unstructured data, it's a journey. And many times I still see in the market people mixing a little bit the facts that what the structured data means, what it means semi-structured or full unstructured data. So just to set the stage, structured data means the databases, right? So CRM, ERP, virtual machines in a way, yeah, this means structured data. Coming from tens of terabytes to hundreds and then petabytes, this is most probably where, of course, artificial intelligence, machine learning starts to be, to become a value for the business. Either could be in the government. I think there was a discussion earlier about a little bit about finance customers, in government, in transportation, healthcare. Healthcare, this is something that we should really start to consider as a citizens first. Just playing around with topics. Do you know that starting April this year, there is one official approved solution, AI solution by the European Union for the imaging? So there is no more, I wouldn't say there is no more doctor in the game, but considering that probably 70-80% of the X-rays are common, why do I need a doctor for each X-ray? So just Google it, you will see it's a company from Lithuania. I was actually having the chance to be in Vilnius and to discuss and talk also about it. They are the first one which is approved already by the European Union. So this is definitely something which is happening in this part of the, I don't know if I should have, do I have this? No, I'm afraid to press the red button. I don't know what does it mean. Okay, so don't press it. Okay. Anyway, this is where things are going in different type of industries. For example, I'm just thinking about the Aerofarm. I don't know if you know, this is a company who is now building a lot of agriculture now on the vertical. If I probably would have the chance to tell to my grandmother about this, she would probably cross eyes to me, you know, how the hell to grow, you know, plants on the vertical when everything should be horizontal. But this is actually what AI, deep learning, it's helping the business with. And as I mentioned, doesn't matter the industries, the fact that these services can be now achieved by, of course, by digital market, by the programmers, by the data scientific resources. You see a lot of use cases, a lot of business outcomes, of course, which can be driven by the analytics and the data coming from the field. These are just couple of examples. To be honest, I don't like so much to give, especially in the Central Eastern Europe, I don't like so much to give these examples from the, I don't know, UK, US, Japan. It sounds something like sometimes like a different planet, you know. But it's a nice thing because you can find actually in some of them, for example, I know very much the University of Pisa, very nice town as well. How they did it from the investment perspective and the business outcomes they actually defined upfront. And this is where you can find more details also on the Dell Technologies website. So, what is then with Dell in this picture? Why do we talk about AI, artificial intelligence, machine learning, where this is usually an application layer, right? Because normally what we see and what usually is going to, it's happening on the customer side, is when we see this kind of, you know, data ingestion, creating islands, because we don't have probably the budget to invest from day one in a full picture. So we start to create islands and to consolidate only for a particular use case or for a particular topic, business topic, right? The analytics, the compute layer, the networking, and the storage. On the other hand, if you remember from structured to unstructured data, when this is growing and we take petabytes or terabytes of data, of course there should be somebody in the room saying that I'm using cloud. Cloud is still an option we'll talk about. What I see, and please shoot at me if you see it differently, I see now, especially with the situation, I would not say the pandemic situation, but mostly what is happening starting this year. IT managers, COOs, mainly CXOs, are looking now somehow to keep the data on premise. I'm not talking about Google now, I'm not talking versus Amazon or Azure or whatever, Alibaba. It's just the fact that people are now, especially probably in the mid-market to enterprise, they really consider to have a footprint of the data as well on premise. I don't know if you follow up, you know, Snowflake, for example, they just actually, beginning of the year, they decided to run some partnerships with some hardware vendors right? Just in order to fulfill exactly this requirement instead of having everything as a service, or to have this option. Anyway, the idea is how I can, consolidate all the data as maintaining the performance, which I probably have already in the classical design architecture, maintaining the scalability, easy to scale, and of course the security. So this is what we see now from both perspectives, because I don't know if you follow a little bit this IT market, but probably you know that Dell EMC was one of the most important companies starting 2000 talking about object storage. Nobody was really listening in the year of 2000 about object storage. Still, the cloud was like, in the early days, right? And it was more about what? Archiving, compliance, which means security, standard security. Today, actually, the object storage is like in a new life. It's a new young generation because the cloud services are based on, of course, on S3 protocol. S3 is the winner of the market versus CAS versus other protocols from the object architecture perspective. So actually what we can do, what we know we can do today with a file system, with a scalability of hundreds of petabytes, actually almost to infinitum, in terms of a file system, having a single file system, and you will see in one, actually, let's say, stack of devices. It's the same on object storage now. So technically, we have the capability to fulfill the same requirements like all-flash, latency, performance, parallelism, and everything also on the object storage. So object storage is not anymore only the archiving mode, but pushed also most probably what I see from the application vendors, it's the new young generation of the storage to come. What would be, I don't have a gift. What do you think outside of the cloud native strategy pushed by, I don't know, document management application, infrastructure management, incident management, whatever type of niche of industry, what do you think are the 1-2 reasons S3 is the winner? I mean, this is what I see, and this is what I see for the years to come. The object storage would take a big piece of chunk from the classical file system. I don't have a gift, so I will answer myself. 2 reasons. Please. Easy of use, yes, but easy of use is like the cloud native scope, right? The initial one. Easy of use, easy to scale, and so on. 2 things, performance. I cannot use the trivial words, but I would use that word before SMB, the protocol SMB, and the same word before NFS, version 3, whatever. Lazy protocols, that's the good word, that's the politically correct word. Lazy protocols, okay, in LAN. But if I go in a geo format, I scream, I die. So that's why performance is one reason. And second is the security. Everybody is talking about ransomware protection. Have you noticed that in the last 1 year or so, nobody's talking about backup anymore? They talk about data protection. There was data management, 1, 2, 3, whatever. Now it's about data security. Pretty much the same, but the scope, of course, is how to seal, how to log the data in an object format. And finally, actually, for the ISVs, object storage gives the advantage that coming from the application, you can lock the data, you can control the data at the destination in the storage. So performance and compliance. These are most probably the 2 main reasons. Of course, easy to scale, easy to use, no doubt about. 2 days, 3 days before I tried to have a communication with one of the partners outside of Romania, but in the region, and they said, yeah, we consider, this object storage stuff, but it seems to be difficult. And this was my initial answer. Guys, it's even easier than what you think about. So you create one bucket, and that's it. Okay, I need to probably follow up with them because they are still scared about this idea. But this is, again, this is coming probably from other guys like me with white hair, right? This is something now that we consider and we look from both perspectives. So data analytics. Let's consider we have, we have a file approach, and we need to address whatever type of use cases. And we get data from videos, from sensors, from IoT, from documents, from whatever file type could exist in this world of the internet and the IoT connectivity. And I need to use, most probably could be different protocols to take this data, because some of the sensors are using, I don't know, whatever type of ingest application or data source. Other type of information is coming from a different source. So I need to aggregate everything in order then the application layer on top to get the best out of this data. But can I do it in a, economical manner, in the same time keeping the performance, keeping the scalability, keeping like one button and then I have an upgrade, and keep all these advantages, which many times, why not, I also see in the cloud, but of course, having a TCO with no egress, and of course, getting the data on premise, because this is probably one of the main reasons to consider such solution. Then it's definitely about, for example, power scale. For some people which may remember or maybe heard about the, you know the name Isilon. Isilon, some guys, end of 2000, before 2010, they came with an idea that somebody in the market needs some easy to use storage in order to address multiple protocols in the same time. So I read NFFS, I write SMB, I do HDFS, Hadoop on top of that, with, for example, big files. Okay, 10, 20 years ago when I said big files, it was like probably tens of kilobytes, maybe 100 kilobytes. Now when I say big files, it's probably at least megabytes or even more, right? Or tens of megabytes. This is what this 1FS, which is actually the file system of the storage, and this is where it fits. Just for, if there are any in the rooms, a little bit of, hardware monkey, they want to see how it looks like. I don't want to go deeper in this presentation of the hardware or how it works, but just for you to know, this is how it scales. So you start with a small stack of nodes, and of course you can grow. Technically, right now, as far as I know, there is one customer which I can call it. It's called Bosch. They have the largest cluster in Europe, 252 nodes. Yeah. The funky stuff is that you can mix up the nodes from different purposes. So you can have archiving nodes, you can have hybrid nodes, you can have all flash array. So you can play having a single file system, always a single file system. You can play on the, of course, on the Ethernet layer, and you can have the applications, the multi-protocol access, and this communication is always like fully bidirectional, fully multi-protocol access, which means if one customer is using a REST API from a whatever application and another one is using NFS or SMB protocol, I can actually mix and read all the data which is inside. Of course, I can create policies about data protection, of how the load balancing capabilities of the stack can work. So for some particular application, I can give better priority, like a QoS, like a quality of service. So I can play with all the SLA which I want, depending, of course, on the user on top. Can I have some users coming from the internet, from the VPN or applications? Of course, it doesn't matter. Can I integrate with an Active Directory or LDAP and so on? Because I mentioned healthcare, for example, it's not the scope of this presentation, but this is also supporting DICOM. So if any of you working within the healthcare system, you probably know that this is the standard protocol by GE, Agfa, Bosch, Siemens, and so on. All these vendors which are now in the digitalization market of the healthcare system. So this is how it looks like. And of course, as I mentioned, there are a couple of different nodes playing on different use cases. I'm not going to spend so much time. Probably one of the sexy one, I would say, for our region is automotive. Not because we are not far away from Germany and they play a lot, but because we have a very nice, it's not actually the border with Romania, but very close. Maybe you heard about Rimac, Croatia. Yeah, they were actually now a part of Bugatti. So still today, they are the fastest car in the world. They use Isilon, they consolidate, they have like 6 cars as far as I remember correctly. They do all the tests for autonomous driving, including the speed, including whatever, multiple thousands of sensors and so on. There is a challenge, but I think it's not yet available. There is one company in Greece who wants to challenge Rimac. Yeah, no, I don't remember the name, but you can Google it, you find it. Also to play in the automotive space and this kind of autonomous driving system and further. This is actually how the initial picture was looking like in terms of, you know, consolidation and working with the application from the 7-layer, from the analytics perspective. So we can, as a customer, we can actually integrate in the same time, you know, for different purposes. One application is actually a Kafka, for example. I take some ingest, and another application is doing the analytics on reporting or whatever in the same time, on the same type, on the same set of data, whatever I define the policies for each particular user or each particular application. Of course, multi-tenant access with zones. I can define load balancing and data services on zones and so on. Talking about Dell and talking about the Dell portfolio overall, whatever would be the use case, you will find actually from the startup kit. I think we call it startup kit for the AI, for the artificial intelligence, where you have, if I remember correctly, it's one precision system. Dragos is over there. He can help you with the names of all this stuff. It's a precision. It's a switch, I think, and of course it's a small power scale. So it actually can help every company to start using such predefined, pre-tested AI entry-level infrastructure, and of course you can grow to whatever technology would need it in terms of you know, business requirements. Very important is that actually I can also have this auto-tiering. So I was mentioning that in PowerScale, talking about file for the moment, file protocols, I was mentioning that I can play with the data. I can use some workloads on an all-flash type of nodes, some other nodes using archiving, like, I don't know, 20 terabyte hard drives, whatever it does. I don't go into these such details, but it's also the fact that I can even auto-tiering to an object storage. So you see here ECS, I will talk shortly about it, but this can be also cloud in the same time. So I can, for example, if I consider that I would like to use Glacier for some, just calling directly, we can call Azure in the same time or Google, so I don't want to have a kind of one hyperscaler mentioned. I can consider that my call data can stay for a long time, for example, in the cloud, because I don't want to pay the egress cost, yeah, but I want to have a very small ROI on the call data, and I can still keep, of course, my space available for the operational processes in the on-premise. Yeah, so I can have this auto-tiering. We call it Cloud Pool. It's just a marketing name. The fact is that I can extend it to a cloud device, either on-premise or off-site. So this is how it looks like from the consolidation perspective of the processes. So if I have, you know, a data store, I have the staging, I have the Hadoop system, and I have again the data storing, depending on how the process works. Everything is happening. All these stages, whatever I use, these are just some examples. Whatever type of process I use, all the data stays here in this stack, in this cluster, in this single file system cluster. Whatever I play with the policy, whatever I consider that, I don't know, for step 1, I need like all flash because I need to low latency and ingest thousands of IOs, millions of sessions and so on. Then I can probably do some tiering and going to a hybrid node, and then I can do some processes or even to archiving nodes. Archiving nodes means that they are a little bit lazier, of course, because that's why they call archiving, but still you have the CPU, and each node offers the power and the CPU, the memory, to support whatever data workloads you define. So this is how it looks like. If the green button works, I do have like 3 examples here. I don't want to take so much on this time. So this is, for example, if you consider to do, you know, interconnectivity with a DR, these are like servers. I mean, it's pretty much the same picture. It's just, I just put instead of arrows and the processes, I just use, you know, some servers, so I can consider that some compute, of course, is needed to run some application, virtual machines, containers, and so on. But always the stack of Icylon is the same. Whatever I do, I can move data and I can play this kind of policies on the data platform. This is a high-level design, a very high-level design of genomic research. By the way, do you know that I cannot mention it. I can mention it because I like it and I'm proud of it. We do have already one institution in Romania who is actually, as we speak, in the process to develop, I think it's the first genomic lab. Yeah, not far from Bucharest. Actually, it's not in Bucharest. I think they work with Illumina. Yeah. You know, when Google asks you to spit on a piece of paper and send it to US in order to give the DNA sequencing, this is technically what it's about, and how you can evolve your life in a more knowledgeable data about yourself, how, you know, what would be your liabilities. I don't know if we became Android or not. It's probably not me. Maybe you are younger. We'll see. Anyway, this is how it looks like. And I want to emphasize and to highlight that this guy, which is, somebody can say, is just a stupid storage, come on. You know, it's not as stupid as it looks like on a slide. It's more than that, because he actually keep the whole processes from the initial sequencing for the ingest of the data to connect to some applications, even in the cloud, if they may run, you know, as a service, you know, to the final report and analyze of the processes. So everything what is happening on each step of the genomic sequencing actually runs because of this guy. Yeah? Because his capability to support in the same time multiple processes, bidirectional, multi-protocol, as I said, you know, in order to support all these stages on the process flow up to the end of the outcome, conclusion, whatever, to the end user, to the customer. Very similar, by the way, it looks for the, especially for the gentleman in the room, in the automotive industries, by the way. So we have here the cars, you know, playing around, spinning or whatever on the special whatever area, polygon, whatever of testing, and then they ingest the data. This is like different type of nodes. They ingest fast on the all flash, and then they run, you know, couple of processes on top. I don't know, some particular applications. Let's call them Ferrari, McLaren, I don't know. Yeah, but it's the same bloody system, I would say, who supports, you know, all these stages. For example, like in this picture, in the genomic sequencing. So, of course, it's about the consolidation, it's about the high computing, it's about extreme scale, and I always keep in mind this easy to use. By the way, what if I need more capacity? What if I need more compute? You know, because you always, of course, you can run some analytics on the system as well in order to identify what you would need for the next process, for the next stage, whatever you like to develop in your business. So it's always the fact that you can put this kind of nodes, you can put an upgrade, you press one button, you have the connectivity. It will probably take like 10 minutes, and then you have the full scalability of the single file system. So it's always a single file system. Data is always spread. God help the mathematics. It's about Reed Solomon, the process which actually chunks the data and protect the data over this cluster. So I would like to also to have a little bit of time talking about the object storage as well. People may ask, why do you talk about file and a separate object? I would say because we like to actually offer to have always an option for the customer. Most probably in time, we will see this as a kind of converging, yeah, file and object. Still today, we do have, looking, as I said, to companies in this kind of mid-market enterprise accounts, they still have a kind of, they try to differentiate a little bit what is happening in the file world, what is happening in the object world. Object is still new, no doubt about. On the other hand, if you can see on this picture, you see CIFS, you see NFS protocols, which I was just talking about, a bit lazy in the file on the Isilon, on a power scale. Why do I have still file here? Because it matters, because we need to support most probably the file workloads, which can actually be embraced then in an object protocol. So I can use then the information coming on the file protocol as part of an object world, whatever application, analytics, AI, whatever I'm doing. Yeah? So this is actually the reason. Of course, there could be multiple purposes and use cases for the object storage. This is how it looks like, just pictures of the, again, I'm talking about nodes and scalability in the same type of cluster that you can scale to infinitum. Actually, there is no limit for ECS, Elastic Cloud Storage. This is also a nice joke. I know I'm recorded. Hopefully nobody will fire me after. Initially, the product was called, the concept was called, I don't know if you know Centera, if you heard about in the past. Again, it's all time ago. ECS is actually the new generation, and they call it Elastic Cloud Storage, ECS, right? But we notice that people in the room, when you talk about cloud, say, no, we don't do cloud. No. Okay, I take the cloud concept and I create it, the system on premise. But I always have to explain that, guys, yeah, there is a word cloud, but has nothing to do with the hyperscaler, especially in the governmental business, right? No, we don't do cloud. Yeah, you don't do cloud, but you like the concept, you like the approach, you like the way, the scalability, the easy to use performance and so on. This is actually what it's about. So I think somehow marketing reacted, and they said, okay, we don't call it anymore Elastic Cloud Storage, we call it ECS. Wow, fantastic abbreviation. Super, but this is all about, and this is, of course, where you see the data lake. Data lake means, as it was in the first slide, we ingest everything. We take everything from everywhere, whatever protocol, whatever sources we have, in order then to have the processing, the machine learning on the same system. The good thing is that I don't need anymore to create islands of infrastructure. Again, I'm talking about now focusing on the on-premises set of workloads. Indeed, like in the file, also in the object, you can expand, of course, to cloud infrastructure. Again, you will see, Cloudera, SAS, Spark, and all these kind of engines for analytics. I mentioned all these technology partners for not only to show off that we do these things, but also to explain a little bit how we do it. We actually certified our solution. There are a couple of labs in Europe, Customer Solution Center, we call it. And these guys actually, they create the lab in order to test with a new version, to do some specific architecture or design for a specific customer. Recently, actually, even these days, we have one customer actually from Romania, and he wanted to test. He wanted to do some test with actually they need 3 virtual machines, if I remember correctly, still virtual machines, in order to do some test. Somebody will say, okay, do you have a cluster to give the customer to test? The answer could be yes, but how much is the effort? Because they really consider to do on-premise. How much is the effort, to do this try and buy from the vendor, from the partner, from the customer perspective? So what we just did, we contact this customer solution center, and we offered a full virtual environment, a real one, to the customer to test whatever application, whatever processes they need. Actually, I just heard from one of our colleagues that he challenged us a little bit more. They want to test also over the VPN. So they want to have some applications from their location, to test on on the cluster, which is in the customer solution center. So this is something that we usually do. There is a long list, I think it's like 250 plus ISVs vendors that we test, we certified our solution, our infrastructure, our data services with this technological partner, as we call them. I was mentioning also about the intelligence that is coming on top of this node cluster architecture, single namespace, single file system, whatever would be the use case. And this is about the data IQ. This is the data storage, monitoring, management, integrated AI solution. So you can actually use it on top, from trends to understand how the data is, who is the owner of the data, how the processes are actually using the resources that you have based on these multiple nodes with CPUs, and how you define the policies to apply whatever data workload to whatever type of performance metrics you would like to get. So this is the data IQ. It's coming on top as an embraced software in order to be able to discover and to manage the data coming, working on such systems. Everything nice about operational stuff, everything nice about archiving, tiering, and parallelism, and all these kind of. What about security? Because now people are talking about scripting, are talking about how to, as I said, less data management, maybe more data protection these days. Question is, how do shall I protect the unstructured data? Shall I be able to protect, I don't know, hundreds of terabytes to petabytes and so on? The answer is, of course, yes. Is it all critical? Probably not. Can I do a backup? That's the easiest question. Yes, you can do a backup, I don't know, tens of terabytes, maybe hundreds of terabytes. You can think about. But usually in the unstructured data, what do we see? We see data which is already compressed maybe, or even some encrypted. And the duplication is not the best in the market to support my backup incremental differential policies to protect the data. So usually in the unstructured data space, where we don't have a clear database, I don't have a clear couple of virtual machines, we don't do backup. So from our experience, because all the systems can be connected to the call support, as we call it, and we monitor also for the customers how the system works. Of course, it's up to the customer to connect to the call home. We see like 10 to 15% of the customer using these kind of solutions, either Isilon, PowerScale, or ECS, Elastic Cloud Storage, doing backup. Technically, in the object storage, you even don't care about the backup anymore. How to do a backup to back up the data, which is object already in object storage on premise. It is possible, but it's like, I don't know, maybe a monkey eating a melon or whatever, a tomato, not a banana. I mean, it's probably not really something that you care about, but you also care about the replication, right? We don't go deeper in the what geo-replication, what would be the policies of the replication to protect the data and so on. But technically, you don't do backup so much on this data because it's a bunch of data, and even a full of backup can take, I don't know, days, weeks, months. It's useless. So then I need to think about how I can protect this data upfront, even in the production. Do I use an antivirus? Yes. Do I integrate with whatever, an IPS policy? Yes. Do I have an IDS device? Yes. Okay. Still, a scripting attack, think about obfuscation, think about a simple, low encryption, or mass deletion of the files cannot be seen by a firewall, by an IPS machine, by a DLP product, or by an antivirus or anti-malware. These are things that are not part of the real, of the classical traditional security way to protect my environment. So what do I need? I need to understand how the data is modified. If I understand, if I have this pattern, if I see how the users from day one to day whatever are actually using the data, and as soon as some anomaly starts, I can at least raise a finger, right? Or I can even stop a particular user, or I can block a protocol, or I can ask the storage itself to create a snapshot immediately so I can figure out what is happening. In case if I have an air gap system, if I have a cyber vault, and I protect some data, I actually don't like so much about this this picture because I see the full stack here with a full stack. I don't need the full stack here. Not the data is not the same. I mean, not all the data is critical, right? So for some critical data like file or objects, I can have, you know, a smaller system in a vault where I do hardening solutions. So whatever could happen here, because nobody gives me 100% security, you know, I can immediately, this is the air gap system, this is unidirectional, I can immediately use the business in a clean room, and in a couple of minutes actually I can support whatever critical application I need until, you know, the forensics, whatever security operations center will understand what is happening in the production. The good thing is that if I feel that some anomaly is happening here, I can immediately, for example, if there is a kind of unidirectional incremental replication running right now, and I have this situation, I can immediately stop it. I can create a snapshot. I can even ask, you know, this guy also to assure the availability of the data, probably in minutes, depending of, you know, tens of terabytes to even to petabytes, whatever would be necessary to give it to the accessibility to the production application. So this is a full stack of the security SLAs that we offer to customers in order to address the data integrity and data security. Again, it's not about signatures, it's not about IPS policies, it's not about intrusion detection. It's about purely what the heck is happening with my data. That's it. That's the only question. And this is how the tool runs. Who wants to see a demo or wants to play with it, just, you know, raise a request to us or to the e-solution, to our partner, and of course we can manage to show you what is about, how it works, how it looks like. So I think it's the last slide. I do have this story about these systems which are in the production, and of course, again, coming back to the initial discussion, what about the cloud? Can I integrate with cloud? Can I have the same file services but running in Google Apps, of course? Or can I have, for example, can I use like Rackspace, which is a, let's call it a broker maybe, you know, of multiple cloud application, because I can have probably different applications running in the multi-cloud environment, but I still want to have a consolidation of everything in one system. So of course I can have it on premise, or I can use it as a service in specific hyperscaler, or for example Faction or Rackspace, which are actually integrating. Rackspace, just 2 weeks ago I had a meeting with them. They offer complete zero egress costs to customers working with Rackspace. So it's up to them. I don't know, by a volume business, I'm not sure how they do it, but you can have this type of file data services like Isilon in the Rackspace, and you can read the data based probably on the subscription, whatever they offer, but you don't care about the potential egress communication that you may have daily, you know, reading the data. Yeah. So this is maybe a good argument also for the multi-cloud architecture environment. So this is it from my side. There was one slide which I missed. I don't know. There was a nice slide with Dilbert. For some, it was a joke anyway. It was a good joke, but somehow it was missed in the presentation. And it was about data analytics, but we already passed the time. Don't worry, don't worry. Thank you so much. If there are any questions, of course, I would love to ask, even in a deeper technical discussion, if it's necessary. Please consider also this from the AI perspective to machine learning to deep learning, this system solutions coming for the unstructured data from Dell Technologies, working with many partners which we mentioned. It was not the scope of today, but I think I mentioned like healthcare, couple of industries we can develop in the video analytics, for example, in the type of media and entertainment market as well. All these projects that we run for different type of vertical solution. Thank you so much. That's it, right?
If nobody
Question.
else wants to ask any questions.
I think it's 6 o'clock or something. Nobody will ask any question. Come on. Ah, there is one. Good. The microphone is dead. Sorry, we don't answer questions right now.
Okay.
It was
If you can please go back to the slide with IoT.
IoT.
Yes.
Aha, the red button. Now I know what red button does. Let's go to you stopped me.
I think you passed.
I
it.
passed.
Yes, with the IoT.
This is about the object storage.
Yes,
This one?
Here,
Oh,
here.
here. Super.
So, what is on average your latency? Because
It depends. Always. I love the IT market. We always answer it depends.
Yeah, it depends.
It depends of what kind of nodes, or for example, of course, it depends of the network. Considering the network is wonderful, let's have this disclaimer. Network is like, I don't know, 25 gigabits per second or even whatever, you know, Ethernet, whatever. So ECS, like the Isilon, can have all-flash array or can have hybrid as well, which means all-flash, we will have probably even less than 1 millisecond at the hardware level. At the file system, at the namespace level, it also depends on the type of objects that you define. So if you think about you are defining millions of objects of 10K, 10 kilobytes. In the same time, let's consider the same application, the same scenario, I'm defining a million of objects of 1 megabyte. Yeah, it's a different. Yeah, so that's why the answer is depends. It's actually the good one, but, you know, the word but means whatever I said before, it's useless. But there is a power sizer, there is a configuration tool that we can define for specific workloads. We can enter it. It's in the Dell Technologies configurator for the partners. And you can define the particular workloads, and you can find out exactly what means in terms of throughput, in terms of different type of objects that you may play it, if it's about ECS. If it's about file system, we usually use SpecFS as the comparison. SpecFS is probably one of the most common standard in terms of performance. Again, if I say 1 millisecond latency, somebody who is doing block storage can kill me after this session. Or maybe not kill me, but, you know, shoot me something. Why? Because he will say you cannot do less than 1 millisecond or 1 millisecond on the file system level, whatever would be a namespace or a file system like NFS SMB. And technically he is right. Because in the unstructured data, you don't care so much as you care about Oracle database or a virtual machine like VMware. VMware says, if you give him more than 10 milliseconds, my applications can be dead. Yeah? That's why in unstructured, you can play a little bit with the latency. At the hardware level, if you consider the all-flash array nodes, yeah, 1 millisecond is there. I mean, even less than 1 millisecond. Yeah? Again, the best way is to use we call it power sizer. Drago should tell you what power means. I don't know. It's just close to you. Yeah, he's much younger than me. It's a marketing name, but in this set of sizers, we actually have for everything, and we use we ask the customer to discuss about the data workloads they have, consider of course the networking and all these infrastructure potentially requirements, and what the configuration would look like in terms of performance metrics, latency, throughput, and so on. So this would be the best way to use the official sizer. But again, hardware level, all flash, you will see less than 1 millisecond. Actually, for example, with Isilon, there is a sub-command in the CLI, in the command line interface, that you can even check what is the level of the hardware response inside each node based on the data workload that you have. So you can even play from this perspective as well to fine-tuning your processes. Did I answer?
Okay, thank you.
Yeah? So, again, sizer is probably the best corporate answer.